Good evening all. Welcome to Pantech eLearning. Good evening all. Welcome to Pantech eLearning. I am Kamalesh. I am from Pantech eLearning. I am a data scientist. So today we are going to see about how the machine learning will be work. This program is organized by Panimalar Institute of Technology. So thanks for this connecting this wonderful webinar on machine learning. And this is like we started with Python programming language, and we seen about Python for IoT application and then image processing. Now we are going to see about Python for machine learning today, and tomorrow we are going to see about Python for artificial intelligence. Okay, so the same timing tomorrow also Python for artificial intelligence. So it will be a most interestful topic. So those who are willing to learn Python for artificial intelligence, so please stay tuned until tomorrow. Okay, so let me enter into the system. So today is all about Python for machine learning. So hope everybody will know about somewhat about machine learning. So today I will teach you in detail what are the use of machine learning and what are the things we are having in machine learning, how to use machine learning things, and then what are the types. Okay, so like this we are going to see in this today's webinar, and moreover how to code the machine learning. Okay, so most of the persons will be know about which platform we have to use the machine learning and how to use the machine learning. Most of the persons don't know about those things. There is some starting problem, right? So we will see on today's webinar in which platform we will use. For example, if you need to learn Python programming language, you can use Python ideally, right? So for that, what type of platform we need to use to execute the machine learning programs. Okay, so like that we will see, and tomorrow we will see about artificial intelligence. So both the combination of machine learning with deep learning is the subset of AI, everybody will know. So tomorrow we will see about. Okay, so today only about machine learning. Let me enter into the session machine learning. Okay, so first of all, introduction. So introduction means like what is the things, okay, how the machine learning will be learned, just a definition. So as a human being, okay, as a human being, from the past experience we learned some new things. For example, if you walk, okay, over the road, you will be hear some sounds like bike, okay, like that car, or some other sounds like lorry, buses. Like that we will hear some sounds from childhood onwards. Okay, so from childhood onwards we are learn from the data, then we are come to some predictions. Okay, so how the machine learning will be, so like same thing only. Okay, so from childhood onwards we are learning some data and we are predicting some result. Like same thing machine learning also. Okay, so machine learning is nothing but machine will be learned from the past data. Okay, machine will be learned from the past experience. Okay, it will be learned from the past experience, like it will be in the form of some data frame, data set, or generally they will call it as a data set. Okay, so data set is nothing but I will tell you in a while. In a few minutes after I will tell you what is the data set and all. Okay, so just you think about, we have a data set, you need to train the data set, and the machine learning algorithm will be give the prediction result. Okay, so this is the thing is machine learning. So if you see the definition for machine learning is an application of artificial intelligence that provides the system the ability to automatically learn and improve from experience. Okay, machine learning focus on the development of computer programs that can access the data and use it learn from themselves. Okay, so generally you have some data. Okay, so there's those data in the form of any type. If it is an data frame type, or if it is some other JSON file or text file, any file, we are training the algorithm. Okay, so here training the machine is nothing but training the algorithms. Okay, so in machine learning we are having different type of algorithm like logistic regression, linear regression, random forest, naive Bayes, k-means. Okay, so these are the algorithm according to the data set we need to use. Okay, for example, if it is a supervised learning, what type of algorithm we need to use. If it is an unsupervised learning, what type of algorithm we need to use. That and all I will tell you in a while. Okay, so here we have a data, we need to train the algorithm. After training the algorithm will be comes to know what are the things. For example, newly if I pass the test data, means based on the new data, okay, it will be give the prediction result, how it's a true or false or any type of continuous value. Okay, like that it will be give the prediction result. Okay, so here highlight of the machine learning program is, if you take an previous programming language like olden programming language, we will give the data and we will give the rules. Okay, so based on the data and rules we will get an output result. But now in machine learning we will give data and answer also. Okay, we will give data and answer, and the machine will be think then which type of rules we need to execute, and then it will be give the output result. So this is the highlight of machine learning. Okay, so here terminology. What are the terminology you need for machine learning means, we need a first of all data set. Data set is the one of the important and key role for both machine learning and deep learning also. Okay, not only for machine learning, deep learning also. Okay, so based on that only it will be trained and give the prediction result. So data set is important. And features. Okay, so here features means in deep learning we don't, this is not an important one, but for machine learning it's an important one. Okay, features means what? For example, I am having a data set, some sample data set. Here you can see that data set, sample data sets. For example, this is diabetes.csv. Okay, so this is the data set of diabetes patient detail. Here we have a data set with some features. So this is called as a features. Okay, pregnancies, glucose level, blood pressure level, skin thickness level, and insulin, BMI, diabetes pedigree function, and then age, outcome. So these are the features. Generally in machine learning they are called as a features. Okay, if it is a deep learning we don't need this feature. Okay, if it is a deep learning we don't need this feature, but if it is a machine learning we need this feature. Okay, so this feature is important. Okay, so important piece of data that help us understand the problem. Okay, so here we have some minimum number of features only we can train as it is, but if you have more than 30 or 35 or 60, 65 like that features will be there, means you need to do some process to taking some important features. Okay, so those process will be called as a, like example, one of the thing is correlation. Okay, we need to use correlation technique and we need to find the important features. Okay, so that and all some important features, some important techniques to take important features, but this feature is important for machine learning. Then model. Okay, what is this model representation means? The representation of phenomena that machine learning algorithm has learned. Okay, so based on the data set, what type of algorithm we need to use, that is important. Okay, here model is nothing but algorithm. Okay, what type of model you need to use to train that algorithm, to train the data set. Okay, so this is a basic terminology. And what are the applications of machine learning, I will tell you. Okay, one by one I will tell you for what type of data set, for what type of model we need to use. Those things and all I will tell you on coming slide. Just we will move on to the applications of machine learning. One of the first application is Netflix. Okay, so Netflix, I think most of the persons will be using nowadays. Netflix is one of the real-time application for machine learning. Okay, so how it's working means in Netflix, for example, if you search, normally if you open the Netflix application means if you wanna search for any movies, you will be search for the particular movie name and then you will be search the movie, right? You will be search the movie and those movie, if it is available, those movie will be give us a result. If it is not available, no result, right? But here in how the machine learning will be working means, for example, suppose if you are searching for science fiction movie, okay, if you are searching for science fiction movies means what are the science fiction collections available in Netflix, all the movies will be available. Okay, if you are searching for romantic movie, all the romantic movie will be available. Okay, otherwise you can search it like even questions also. Okay, in which movie Iron Man will be come, like that also you can search. So that is one of the real-time application of Netflix. And next one is Facebook. So Facebook, this I hope everybody will know about this Facebook. So if you wanna post any photography, automatically it will be predict your friends' faces also. If it is a group photo, your friends' faces also automatically it will be give the prediction. You need to tag your friends, like those things and all. Okay. So like same thing we have in Google Photos also. Okay. So when you are uploading your personal photo or some other photos to your Google Drive means automatically it will be collect all the index of the each faces. Okay, so those things and all by real-time machine learning only. Okay, then PayPal, not only PayPal, PhonePe, Google Pay, those things, and then Uber, Amazon, FIFA. Okay, so these are the area we are covering for real-time applications of machine learning, and most important thing is Uber only. Okay, in Uber you can see the how is machine learning. For example, if it is a Uber Eats or Zomato, if you are searching for any food also, it will be automatically give some prediction result. Okay, then after that, if you just exit the app means within few minutes, within 5 or 6 minutes or 8 minutes, you will be get a notification, your food is waiting for you, please order, like that you will be get one notification. So those things under it's by a machine learning only. Okay, so when you are not ordering, automatically it will be give the notification, please order, like that. Okay, so this is under machine learning. So these are the important applications we see until now. Okay, so these applications and all we using not only those things, even if you take a smart watches. Okay, so using smart watches, lot of machine learning are there, lot of machine learning process will be there. So those things are one of the real-time examples. And now we will enter into the topic of types of learning, types of machine learning. This is one of the important things. Why? Because till now we learned about what is machine learning and what are the applications of machine learning. Okay, and for machine learning what we need, data set is need, we learned everything, we learned, right? So now just assume that you have one data set. Okay, so you have one data set, you need to develop one project based on machine learning, or you need to train you need to give that data set to the machine. That is, machine means nothing but algorithm, to train the algorithm. Okay, so what type of algorithm you need to use? Okay, whether it's a supervised learning or unsupervised learning. Okay, so this is important. So if you need to develop one project, you have a data set. So the next step is choosing the algorithm. Okay, choosing the algorithm, before you need to know what type of data set you are having. Okay, whether it's a supervised learning, or whether it's a unsupervised learning, or whether it's a reinforcement learning. Okay, so here you can see supervised learning, unsupervised learning, and reinforcement learning. Totally we have 3 types in machine learning. So now just assume that you have one data set. Okay, so if you wanna move to the next step, you need to know which type is among this: unsupervised learning, reinforcement learning. Basically, if you are downloading any dataset from online, you will be have this two only, supervised learning and unsupervised learning. Okay, so the next step is how to find supervised learning, unsupervised learning, and reinforcement learning. So it's a simple thing. Okay, it's a simple thing. If you have a data set, with output column, okay, if you have a data set with output column, that is called supervised learning. Okay, if you have a data set both input and both output, that is called supervised learning. If you have a data set without output column, only you have an input column, that is called unsupervised learning. Okay, so supervised learning is nothing but with input and output, unsupervised learning is only input. Okay, reinforcement learning is like a game. Okay, it's like a learn from the rewards. Okay, whether it's a positive rewards or negative rewards. Okay, it will be learned from the rewards. Okay, so for example, if I have a one environment, if I for example I am going to the new place. Okay, new place for like any place like America or any country. Okay, I am going to the new country, so based on that country I need to adapt. Okay, for example, if I in that new country I am driving the car, means I need to learn some according to those rules and regulation. Okay, so you need to choose correct, you need to choose the indicators, or you need to go speed at the speed limit, those things and all I need to learn. Okay, sometimes if I go speed and if I capped by an police, means that is negative rewards. Okay, so I need to learn from the negative rewards. Sometimes if I follow the correct rules, means it's a positive rewards, so I learn from the positive rewards. Okay, so like that it's a reinforcement learning. Okay, so reinforcement learning will be trained based on the ecosystem. Okay, so about reinforcement learning we will see, but what is supervised learning and unsupervised learning? It's an important one. Let's we see one by one. First of all, what is supervised learning? So supervised learning, I already told you, I will train the machine with output. For example, here we have simple example. I am training, I have a data 4 into 4. I am having a data and I am telling this assume like it's an algorithm. Okay, it's one of the algorithm. So I am training the algorithm with giving data and output. So here I am giving a data and output. So I am telling to the machine, if it is a 4 into 4 is equal to 16 is the right answer, and if it is a 2 into 5 7 means it's a wrong answer. So I am telling to the algorithm both right answer and wrong answer. Okay, based on that it will be trained that is called supervised learning. Okay, so let we enter into, so in supervised learning we have only two types. Here one of the example, it's the easiest example. Here I am having a bunch of apple and I am telling to the machine this is the apple. Okay, I am giving to the model apple and I am giving to the model it's a apple. Okay, so whenever I am giving new apple to the model, definitely it will be give the prediction it's a apple. Okay, so it's a supervised learning. In supervised learning we have only two types. One is classification, next one is regression. Okay, so one is classification, the next one is regression. So let me see one by one what is classification. So classification is nothing but if you need to predict an output result, whether it's a good or bad, whether it's a true or false, whether it's a 0 or 1, like that if you need to predict an model, means that is called classification. Okay, so here I am showing the example. We have totally predict two types, one is good or bad. Okay, so when I am giving an input, new input 20, 15, so it will be in the side of good, so my model will be predict an output good. Okay, so for this classification type, if I want to show you one simple data set for this classification type, means we previously seen that data set, that is the data set of diabetes.csv. Okay, so here what is the main aim for me? We need to predict whether the patient will be attacked by diabetes or not. Okay, diabetes or not. So diabetes or not. Okay, so I am having some report of patient, okay, like glucose level, blood pressure level, skin thickness level, insulin, BMI, those data I am having. Based on the data, this is the one person's patient details. Okay, so based on the data I am having an output result. So here 1 means the person attacked by a diabetes, 0 means not attacked by a diabetes. So like that I am predicting the result based on the zeros and ones. Okay, so this is called as a supervised learning classification type. Okay, and the next one, regression type. So regression learning is nothing but we seen previously. If it is a supervised learning classification type means my output will be within range. If it is a 0 or 1, even if we have a multi-class also 0, 1 or 2 also, within range we can find this is the prediction result within range from 0 or 1 or 0 or 1 or 2. Okay, like that we need to predict the result. But in regression learning you cannot define what is the range of your prediction output. Okay, so suppose if it is 100, or suppose it's a 200, or suppose it's a 20. Okay, we cannot define, it's a continuous value. Okay, we cannot define the prediction output within it's a range, like that we cannot predict. So it may be increase or it may be decrease. So that is called regression type. So one of the more example data set for this regression type, here I am having an insurance.csv file. Here I am having an age and sex, BMI, children and region. Okay, the region is southwest or northwest, and charges. Okay, so here you can see this is one of the detail about one person, and here one person. Here the first person need to pay 16,884 and second person need to pay 17,225. So here you can see based on the those things. Okay, based on the, actually in machine learning this data will be called as a independent data. Okay, independent data means based on this independent value only we are having this dependent column. Okay, so based on the independent data we are having some result. Based on the independent data we are having some result. So we cannot define within range. So this is called regression. If you need to predict like this type of continuous value, it's a regression type. We need to use the regression type of algorithm. Okay, so note one thing, for classification also we are having separate algorithm, machine learning algorithm. For regression type also we are having a separate machine learning algorithm. Okay, the next thing here, one of the supervised learning algorithm, first one nearest neighbor algorithm, KNN, and naive Bayes and decision tree and linear regression and support vector machine and neural network. Okay, so these are the supervised learning. Note one thing, for example, if you take support vector machine can train both classification type and regression type also. Okay, you can train the support vector machine for both classification type and regression type also. So like that it will be have even decision tree also like same thing only. Okay, so these are the algorithms for, actually this is just a 7 algorithm I showed you, but we have a lot in classification and regression also. Okay, so it's a supervised learning. Now unsupervised learning. Unsupervised learning, I already told you, we will take it as an example of our diabetes.csv file. Okay, suppose here I am having an output whether the diabetes will be attacked by patient or not, right? Suppose if you have a data set without this dependent value, only you have a independent value, this is called as a unsupervised learning. Okay, so you need to find some cluster. Okay, whether the, for example here what is the cluster, we need to find the two cluster whether the patient will be attacked by diabetes or not. But I don't know how many clusters of data will be there. Okay, so using k-means algorithm or hierarchical clustering algorithm, you need to find those clusters. So that is the use of unsupervised learning. So here you can see I'm having a data like circle, square and triangle. Okay, I'm not telling to the model it's a circle, it's a triangle, it's a square. Okay, so based on the attributes, based on the features of the data, automatically it's predicting that is clustering the output result. Okay, so this is the unsupervised learning. In unsupervised learning we have two types. One is clustering and another one is association. Okay, one is clustering and another one is association. First one is clustering. Clustering is nothing but if you have a original data, it will be find the n number of clusters. Okay, so it have original data, it will be find the n number of clusters. Okay, here you can see this is the original data. In this original data, I don't know how many cluster of data. Okay, so I am using k-means algorithm. For example, you can assume that I am using a k-means algorithm. Then using k-means algorithm, I will find that totally I am having a 3 clusters in my original data. That is 0, 1 and 2. So that is called as a clustering type. So for clustering type, I am having a one data set, that is customers.csv. So here you can see this is the data set without dependent column. Okay, we need to find the dependent column. I don't know, actually I already trained this data set, and I find for this data set totally 5 clusters. Okay, so how you need to find the clusters means, if you are using a k-means algorithm, you have in k-means algorithm you have separately to find the cluster, n number of cluster, you have a method, it's called as a elbow method. Okay, using elbow method we need to find the how many number of clusters we are having in this data set, and based on the elbow method we will find the clusters and we will train the algorithm. Okay, so this is the thing we are using in clustering learning. Next one is association learning. Association learning is like a recommendation. Okay, so based on the previous customers history, your machine learning algorithm will be give the prediction result. Okay, previously if the customers bought a milk, means automatically it will be give the suggestion. Also you need to bought like coffee powder or banana, like that. Okay, so this is the association learning. Generally, like we have a movie recommendation. Okay, in data set also available. Like that we are having some data set for association learning also. Okay, so this is called as a machine learning, supervised learning and unsupervised learning. Okay, I hope everyone will understood about this. I am moving to the next one. Next one is for unsupervised learning, what are the algorithms we can use. So I already told you we have k-means clustering and association rules, and we have hierarchical clustering also. Okay, so for unsupervised learning algorithms. Now next one, reinforcement learning. I already discussed you, it will be learned from the experience. Okay, we are not giving any data, it will be learned from the ecosystem based on the rewards. Okay, based on the rewards it will be learned from the ecosystem. So that is the use of reinforcement learning. And for reinforcement learning we are having like Q learning and temporal difference, this TD, and deep adversarial network. Okay, so these are the 3 algorithm is currently we are using. Q learning is one of the most popular one for reinforcement learning algorithm. The next one, what are the library files you need to use for machine learning algorithm. Okay, so first file is pandas. So pandas is nothing but to read the CSV file or text file or JSON file, you need to use the pandas. So generally the pandas for data frame type, here you can see, here I am having a data set of 3 different type of data set. This all are in the extension of .csv file. Mostly your dataset in the form of .csv file if you are downloading from the online. So those files you need to read, means you need to use pandas. Okay, so generally pandas have series type, data frame type, and even 3D also. Okay, so most of the dataset in the form of 2D, that is data frame type only. Okay, so this is one of the library files you need to use. And then next one, NumPy is generally called as a numerical Python to like build the array values, those things and all, and mathematical calculations and all, we are using NumPy. Then Matplotlib in name itself we have a suggestion like to plot a graph, to plot a different type of graphs by using Matplotlib. And combination of Matplotlib you can use even Seaborn also. Okay, so Seaborn is one of the graph. By combination of Seaborn and Matplotlib we will use the algorithms. Okay, then next one, sklearn. This is one of the most important library packages for machine learning. Like if you need to import the algorithms, or if you need to train the algorithms, or if you need to split the data set into two types like train and test, though for those purpose we are going to use this sklearn package. And then next one, NLP, natural language processing. If you have a data set in the form of text type, okay, you need to use this NLP technique. And note one thing, here you can see the data set mostly in the form of numerical type. Okay, mostly in the form of numerical type. So if you have a data set in the form of, like, this is generally called as a categorical type. Categorical type means we can easily convert this male as a 0 and female as a 1, or female as a 1, male as a 0, like that you can convert and easily you can do. But if you have a text type, okay, the conversion is difficult. Okay, so that's why we are using this method. Okay, so conversion is difficult, so that's why we are using this NLP technique. So in NLP technique we are having some different type of steps like tokenizing, or word stemming, or stop words. Okay, like that we are having some techniques. Those techniques are just cleaning the text only, but after cleaning the text you have some techniques to converting the text into the vector. Okay, why you are converting the text into the vector means then only algorithm will be understood your data. Okay, so what are the techniques available for converting your text into the vector means like back of words, BOW, and word to vector, and word embedding. And not only these three, we have another one, TF-IDF. IDF. Okay, TF-IDF is nothing but term frequency inverse document frequency. Okay, so like this we are having some steps. Using those steps we need to convert your text data into a vector form. Then after that you want to train the machine learning algorithm. Then machine learning algorithm will be understood your data, text type of data also. Then you can find the result. So these are the packages we are going to use in machine learning, Python libraries. Okay, the next one, process. So generally if you are taking the process in machine learning means it's a common process only, like data collection. First of all you need to collect the data set. After collecting the data set you need to do some data preparation. Okay, data preparation is nothing but you need to do some future engineering. Future engineering is like you need to check whether your data set having null values or not. Otherwise, whether your data set having a text type or categorical type. So if you have a categorical type, you need to convert those categorical type into zeros and ones. If you are text type, you need to do some process with the NLP, and after that you need to move on to next one. The next one is nothing but like checking null values or not. I think that one I already told you. And we need to do some normalization or standardization, that is converting your data types into an equal. Okay, if you have all the features with the same data type means it's easy to learn by your machine learning algorithm. Okay, so those things and all you need to do in data preparation. After you done this in data preparation, you need to move on to model fitting. Okay, model fitting is nothing but you need to train your model. Okay, by using your trained data, you need to train the model. Model will be learned from those past data. Okay, after you train the model, you need to evaluate the model. That is, you need to give the test data to the model. Okay, so test data means like we already have some test data, otherwise you can newly give the input of your test data, then your model will be evaluate and give the result for those test data. Okay, in model evaluation we have some steps are there, like confusion matrix, accuracy score, those things and all there. We will see about those things. Okay, if your model evaluation result is not a good one or not predicting properly, you need to do some hyperparameter tuning. Okay, so hyperparameter tuning is nothing but you need to change some parameter in your model, and then you need to train the algorithm. For example, if you take a linear regression type of algorithm, you need to change the polynomial 1 or polynomial 2, polynomial 3, like that. You need to change some model things and you need to get the accuracy result things. Okay, so these are the process you need to do in machine learning. And here working with data set, so first you need to gather the data, import the package. Data analysis is nothing but plotting some graphs, and data analysis, like what are the data available in your data set and what are the columns you need important and what are the columns not important, whether it's a supervised learning or whether it's unsupervised learning, like those things you need to see in data analysis. And data visualization is mainly for plotting the graphs, whether you have outliers. Okay, that is important. For example, I missed previous slides. Actually, in data preparation we have another one method. Those method is called as outliers. Suppose for example you can see the data like 1, 2, 3 and 4. After 1, 2, 3, 4 you are having an data like 50 or 100 or 200. Okay, so you just see this data, your mind will be automatically think one thing, that is 1, 2, 3, 4 are different and 50, 100, 200 are different, right? So this is generally in machine learning called as the outliers. Okay, outliers. Okay, so you need to remove those outliers by plotting some data graph. Okay, so like if you need to check means like you can use the box plot to find the outliers in your data set. So these outliers and all during training time it will be affect the algorithm learnings. Okay, so for that purpose we are going to use those outliers. Then data pre-processing and model selection. Data pre-processing, I already told you, we need to do some normalization or standardization. That is, if you have a int 64-bit type of data like 234, like that means you can convert into an float value like 0.234, like that. Something you need to do normalization or standardization you need to do. Then after that model selection. So based on your data types you need to choose your model, which type of model you need. Okay, whether it's a supervised learning or whether it's unsupervised learning. So these are the things. It's an important one to choose in machine learning. After model selection you need to train the model and you need to test the model and evaluation. Okay, so this is the working process with the data set. And here model selection we already know, like we have a different type of algorithm. If it is a supervised, if it is a classification type means you need to use those algorithms. If it is a regression type you need to use linear regression or support vector regression. And if it is a clustering type it's a k-means. So this is a general algorithm mostly applied by a data scientist. So that's why I am showing you what is the model selections you need to use. Then train and test fitting model. Okay, so this is one of the most important technique in machine learning. Why? Because based on this only your model will be learn how it's learning and how it's predicting the result. Based on this only you are going to check the result. Okay, for example, I am opening the Paint here. In Paint, if you can assume that you have one data set. This data set you need to do some process like feature engineering and feature selections, some process we discussed in previous slides, right? So those processes we are doing. After you done those process, you need to move on to like divide your data set into two types. For example, you can assume that you have 1,000 data. Okay, those 1,000 data you need to divide into like train and test. That is divided into two types. One is train, another one is test. So train should be always like 80% or 75% or 70%. Test should be always like 20% or 25% or 30%. Okay, so you need to divide your data set into two types. One is train and test. Okay, so for example, during this time, okay, I am dividing after this time. After this, I am going to train the algorithm and I will predict the output result by passing the test data. Okay, but in train data, I will be have both. What is that? Independent value and dependent value. Okay, here also I am having independent value and dependent value. But during testing time, testing the algorithm, at the time I will be give only an independent value to the algorithm. Algorithm will be give the output that is dependent value, that is 0 or 1. Whether it's a classification type means 0 or 1, like that it will be give the prediction result. Okay, so that is the train and test fitting. And evaluation. In evaluation you can see by using accuracy score. Okay, after you are here you can see in Paint you only given an independent data, so I will get a dependent data from the algorithm, but I already have original dependent data in data set, right? So I will compare this result. Okay, I will compare this result. So if it is a matching, if it is similar to previous algorithm prediction and my original data set, you will be get one score value like 0.95 or 0.80. So this is the generally called as accuracy score. Okay, you can get a result of your test data. Suppose if your data set in the form of imbalanced manner. Okay, I will tell you what is imbalanced manner. Here you can see. Actually this is imbalanced manner. Okay, so that is, for example, you can assume that it's a 0, it's a 1. So 0 I am having a low data value and 1 I am having a high data value. For example, in 1000 data values I am having a 900 data value as a 1 and 100 data value as a 0. Okay, so this is generally called as a imbalanced data set. Okay, so if you have an imbalanced data set, you need to, that is, if you have an imbalanced data set, you need to do some process. Okay, so if you want to check those things, you need to use this confusion matrix. So confusion matrix is always 2 into 2 matrix type. Like this is generally called as a true positive, and this is generally called as a true negative, and this one is false positive, and this one is false negative. Okay, so generally this area will be called as a error 1 and error 2. Okay, you need to reduce these errors to achieve the, if you reduce these errors, okay, if you reduce those errors, if you achieve this as a like every data will be in a true positive and true negative, means on the time your model is learned properly. Okay, so this is the one of the evaluation process. So checking of accuracy score is, if you have a balanced data set, checking of accuracy score is better. But if you have an imbalanced data set, you need to check this type of confusion matrix, and you need to achieve this error rate 1 and error rate 2 to as a minimized error. Okay, so that is the use of evaluation. Next one, problems and algorithms in machine learning. So this is the one of the major problem in machine learning, that is underfitting, overfitting and optimal. Okay, what is underfitting? Underfitting is nothing but if you have a during training time, okay, during training the algorithm, your model will be not learned properly. That is, if during training time they will call as a bias, and during testing time they will call as a variance. Okay, so during training time, if your model is not learned properly, that is, if your model learning is low, then your prediction result of your, that is during testing time also, your model will be give the low accuracy result. Okay, that is your bias will be a low and variance will be a low. That is called underfitting. If it is a overfitting, okay, during training time, okay, that is during training time is nothing but bias value will be a high, but suppose if you have a test data here and all, if you have a test data here and all, that is your variance value will be a low, so it's lead to overfitting. Okay, so if you have a bias value low and variance value also low, that is underfitting, and if you have bias value high and variance value also low, your accuracy will be a low. So we need to always achieve this optimal fitting. Okay, you need to achieve always this optimal fitting. So if you achieve this optimal fitting, your accuracy result also high, your bias also medium and your variance also medium. Okay, so this one you need to do. So this is an important technique. So how you can do this thing means, first of all you need to check whether you have a balanced data set or imbalanced data set. Actually this is the graph of imbalanced data set. You can see we having more orange values compared to those blue values. Okay, so this is generally called as a imbalanced data set. So you need to convert those imbalanced data set into an balanced data set, means you have to move to the next step. The next step is called sampling. Okay, so sampling is one of the technique. You can convert your imbalanced data set into a balanced data set by using these two type of technique. The technique is called as undersampling and oversampling. Okay, so undersampling is nothing but you just, here you can see in undersampling, if you have a minority class and majority class, your majority class will be equals, that is I am just deleting most of the data and I am saving as a equals to my minority class. That is called undersampling. Oversampling is nothing but I am duplicating, that is copies of the minority class that is equals to the majority class. That is called oversampling. Okay, so based on the data availability, you can do either undersampling or oversampling to achieve the balanced data set. Okay, so if you are training the balanced data set, you will be not it will be not leads to underfitting or overfitting. It will be leads to only optimal fitting. Okay, so that is important. And even though if you have a balanced data set, you need to do this process, that is cross validation. Cross validation is nothing but where you need to apply this cross validation. So we already discussed in here, right? Here is nothing but we have 1,000 data set and we need to divide the data set into train and test. After we are dividing the data set into train and test bed, we need to train the algorithm and we need to pass the test data and we need to create an output result, right? So this is generally you can apply using sklearn package, and using train and test bed function you can divide the data set into train and test, and you can train the algorithm and test the algorithm. This is general thing. But suppose during dividing the data set, for example, if you have a zeros and ones, okay, if you have a zeros and ones prediction output, that is 0 means, for example, you can assume as a diabetes patient, and 1 means not a diabetes patient. Okay, so during dividing this data set, all the suppose I am telling all the data, that is all the zeros values will be move on to the train data, and all my once data value will be move on to the test data, means it leads to error. Okay, So that's why we are using this cross validation. So we are training the algorithm by part, okay, and we are getting an output result. So that is called cross validation. Okay, so just wait a minute. That is called cross validation. Okay, so if you have any doubt, so that's it about I need to tell you. So if you have any other doubt until, you can ask it in our comment box. So those who are new to this channel, please subscribe the channel and hit a bell icon. And if you like this video, please hit a like button. It will be really helpful for us to motivate like this. And those who are new to the channel, please subscribe the channel. You will be get a notification each and every day. And tomorrow is artificial intelligence, and we are posting the attendance links. Please use the attendance links and fill your data. You will be get a certificates. And if you have any other doubt regarding this webinar, you may ask hyd.java@pantechmail.com. And we have a WhatsApp also. If you need further more information or regarding upcoming event, you may ask on 7010888841. And we have Telegram channel also. You can join with us, Pantech eLearning. So thank you for this wonderful webinar connecting by Panimalar Institute of Technology. And we will see you on tomorrow regarding about artificial intelligence. It's signing up from Kamalesh. Thank you all.